this is what we did last time. We basically just defined what a pointer was. We looked at some different ways to use pointers. Now we want to look at the relationship between arrays and pointers. So we already know that the array name is actually a pointer that's pointing to the first element of the array. So remember, the array name is the address of the first element in the array. So let's say that we have an array, and I'm just going to call this int val, and then let's say that we have these values in this array, so 20, 40, 60. I'm going to draw the array too, so we can just picture this visually as we're going through this example. But we have 20, 40, 60 stored in this 3-element array. This is element 1, 2, and 3. And so if we do a cout vals, yeah, this is going to display the address of the first element. So the name of the array is the address of the first element. What if we do cout vals 0? And then what if we do cout star vals? So this is the vals is the address of the first element in the array. So if we dereference that, this is going to display 20 because that's what we have stored in that location. So knowing that, what if we did something like cout vals +1? So this is going to display 40 because so we've incremented the address by 1, so now we're at the next address in the array. So this is going to display 40. And then what if we do cout, and there shouldn't be a space right here, so vals +2. So basically this means, like, let's just look at this. This is basically what we're doing is we're taking the address of val and then we're adding 1 times whatever the size of whatever we have stored in the array is. So remember the size of, and right now we have an array of integers, so this is going to be size of integers. So that's going to be the address of val plus 1 times 4. So this is going to increment us to, we're at this element in the array, this is going to increment the address to the next element in the array, which is 40. And then if we add 2 to that, it's going to increment us to the 3rd element in the array. And then if we had, say, double here, like if we had size of double, it would increment, assuming that we have a double, which I believe is 8. So, and you don't need to include this size of. If you just put the vals +1 or vals +2, it's automatically going to do that for you. Basically, what we can do with this is we can equate. So we've already seen that we can go through an array like this. So this would be like the index notation. This is called index notation. Or we can access an array with what's called pointer notation. And that's this vals plus I, and then I is whatever increment we want. So this one would be pointer notation. And so you can basically do everything you've already done with arrays. So we can do everything we've done with arrays using index notation with pointer notation. So you still want to keep a few things in mind. First of all, there's still no bounds checking, so it's possible to give the pointer an address outside of the array. So you still have to be really careful not to go outside of the bounds of your array. So basically you could still have an off by 1 error with this. So let's look at some actual code with this, and just to save time, I'm just planning on showing you some code that's in the chapter. So this is program 9-7. Just make this a little bit bigger. And we'll just go through this and see what's going on. Okay, so let's go up here. So this program uses subscript notation with a pointer variable and pointer notation with an array name. Basically, this is just we're going to have an array, and we're going to go through the array using both index notation and pointer notation to see that you can basically use these interchangeably. So let's just go through this. So first of all, we have our array that has 5 elements, and then we've put those in there, so 0.05, 0.1, 0.25, 0.5, and 1. And then we have a pointer called double pointer, and this has to be a double because our array is a double. And then we have our counter. This is going to be the array index. And then this is where it might look a little bit weird because we have double pointer is equal to the name of the array is the address. So we can just set the pointer equal to the name of the array, and that's going to store the address of the first element in the array to our pointer. So with the regular variable, remember the variable you have to do the ampersand to get the address, but this time we don't need the ampersand because because coins is the address. So we have a cout statement, and we have here are the values in the coin array, and then we have our loop that we're stepping through the array. This one we're accessing so we have double pointer, and then we have count. This looks a little weird, but we can do this because double pointer is equal to coins, which is equal to the address of the first element of the array. So this is one way that we can use the pointer instead of the name of the array to step through the array. The other way is the way I just showed you. So we have here are the values of the coins in the array. So this one we have our double pointer plus count, and we have the star so we can dereference what's in the address of the array. So we have star double pointer plus count. The first time we run through this, it's just going to be double pointer plus 0, so that's going to display what's stored in the first element. The second time we run through this, it's going to be double pointer plus 1, so that's going to increment our address to the second element in the array. And since we have the star, we're dereferencing what's stored in that second element, and we're displaying it, and so on. So these are 2 ways that we can display or manipulate what's in an array using the pointers. We can also use both of these notations with the name of the array, because the name of the array is actually a pointer. So it's the address, it has the address of the first element in the array. So with this one we have cout, and then coins plus, the first time this runs through, this count is 0, so we're just dereferencing the address of the first element in the array. So that's going to display what's stored in the first element. Second time through, we add 1. So now we have coins plus 1, so now we're at the address location of the second element in the array, and that's going to display what's in the second element. And then this is the notation that we've been using. So this is basically 4 different ways that you can access things in an array.